Today we are going to present our project on privacy-preserving multi-party neural network. So our targeted problem is a situation where we have n participants, each processing an individual dataset, and none of the participants wants to share their dataset, know their identity with each other. So the goals that we want to achieve is first that each dataset D1 to Dk should only be kept to the party that possesses it. And second, the computed model cannot be reverse engineered to learn about any individual data instance. So the approach that we have chosen is first to examine two papers that target this particular issue. And second, we have implemented two models similar to the proposed models studied in the paper. So the first studied model is a distributed gradient descent neural network. So each participant will upload a portion of the most relevant parameters to a central server and then download a portion of the most updated parameters. So this is what happens during the local training, and this is what happens on the server side. The pros of this approach is that the local models can be trained asynchronously, and the resulting accuracy is only slightly compromised in exchange for privacy. However, the uploaded parameters could reveal certain information about the parameters. Then the second model that we have studied is an aggregated logistic regression classifier, where we take the average of the weights plus a norm from Laplace distribution in order to ensure that the parameters cannot be reverse engineered. And our first implementation consists of passing on parameters to the next participant using deep learning. So a participant will use the weights from the previous participant in order to train, and the last participant will share its optimal weights with each other. The results of this approach are pretty close to decentralized training, and the participants don't share any data set with each other, and however, the participants will know about the identities of each other, and this training can only be done in a sequential order. The second approach is done by averaging parameters. So each participant will upload a set of weight plus a noise term, and the server will compute the average, and each participant then downloads the weights. So the results, as we can see, are pretty good also. So in this approach, the data of from each participant cannot be reverse engineered because of the noise term. However, the users have to trust the centralized server to keep their identity private.